Good day everyone. Here we are again in my channel to study and learn from a video lesson. Let's start with the saying, anything that goes up comes down. In physics, this observation is true, that whenever you throw an object upward, in a short while it fell back. Today, in this lesson, we will be dealing with freely falling bodies. There are several misconceptions about freely falling bodies. Some of these will be tested as you proceed with this presentation. Take this opportunity to learn from this video lesson by viewing the video to the end. Try also the problems posted to test your understanding of the topic. Freely falling body. Is the motion similar with bodies moving along the horizontal? The distance traveled, the velocity, acceleration, and time of fall will be explored in this lesson. In the following illustrations, is the ball a freely falling body? The ball was released from a vertical distance. As it moves downward, is it a freely falling body? What is your answer? A yes or a no? Most of you will say it is a freely falling body because the ball is falling, in the sense that it moves towards the center of the earth. How about this? The ball was thrown vertically upward. As it moves upward, is it a freely falling body? What is your answer? A yes or a no? Many of you will say no. Why? Maybe you will say the ball is moving upward, so it's not falling. That in the sense of falling, the ball is moving away from the earth instead. At this moment, I will not confirm nor negate your answer, and I want you to find out as the video lesson progresses. Considering the entire motion of the ball thrown upward, that after moving upward, it then moved downward, is the ball a freely falling body? At this point, what is a freely falling body? A freely falling body is defined as an object that moves under the influence of gravity only. Gravity or gravitational force is the force exerted between two bodies by virtue of their masses. Because the ball has mass, a gravitational force is acted upon by the earth on it. Going back to the ball released from a vertical distance, as it moves downward, what force or forces act on the ball, disregarding a resistance? Isn't it that only gravitational force or gravity acts on the ball? Is the hand that held the ball exert a force on the ball after it was released? No, because neither the direction nor the magnitude of the speed of fall of the ball can be changed by the hands while moving downward. The increasing speed is due to the gravitational force that continuously pulls the ball downward. How about the ball thrown vertically upward? As it moves up, what force or forces act on the ball, disregarding a resistance? Maybe you will say, one is the gravitational force, Are there other forces acting on the ball as it rises from the hand? I bet some of you will say the hand exerts force on the ball as it moves up. Truth, while the hand is holding the ball, force is exerted on it. But is the same hand that held the ball exerts a force on the ball after it was released? No, because neither the direction nor the magnitude of the speed of rise of the ball can be changed by the hands while moving upward. The decreasing speed is due to the gravitational force that continuously pulls the ball downward. So the only force acting on the ball while moving downward or upward is the gravitational force. Because the only force acting on a ball thrown upward, gravitational force, is it a freely falling body? Yes, it's a freely falling body. The ball is a freely falling body whether it is on the upward or downward motion. What motion has a freely falling body? Let's observe again the motion of a body thrown upward and the body released from a height. Notice that the distance covered by the ball decreases as it moves upward and increases as it moves downward. The ball is accelerating. Is the acceleration of the ball constant? Note that the object is constantly acted upon by the gravitational force causing the body to accelerate. Because this is the only force acting on the body, the acceleration is constant. Thus, the motion of a freely falling body is a uniformly accelerated motion, UAM. I hope you have viewed the video lesson on uniformly accelerated motion before you open this presentation. If not, or you want to review about this, there is a video lesson about the equations of kinematics in this channel. The video lesson on equations of kinematics will help you a lot in understanding the lesson in this presentation. What is the direction of the acceleration of a freely falling body? As the body moves upward, these dots represent the position of the ball in the same period of time. As the ball moves upward, the distance covered by the ball decreases. The displacement of the ball is directed upward. The velocities of the ball, v sub 1, v sub 2, v sub 3, and v sub 4. The speed of the ball decreases and the velocity is directed upward. Remember the discussion on accelerated motion. Acceleration can be positive or negative. This is an analysis from the instantaneous velocities, that if the velocity is decreasing, the directions of acceleration and velocity are opposite. So if the velocity is upward, the acceleration is opposite to the direction of the velocity. Thus, the acceleration is directed downward. For a body moving along the vertical, and to differentiate the symbols used from horizontal motion, the distance traveled by the body along the vertical is y, and the acceleration is termed as acceleration due to gravity. The symbol is g. Continuing, what is the direction of the acceleration of a freely falling body? For a body released from a vertical distance, the dots represent the positions of the ball. As the ball moves downward, x sub 1 is less than x sub 2 and less than x sub 3. The distance covered by the ball increases. The displacement is directed downward. The instantaneous velocities v sub 1, v sub 2, v sub 3, and v sub 4. The speed of the ball increases and the velocity is directed downward. Remember that for an accelerating body, if the velocity increases, the acceleration and the velocity are in the same direction. The velocity of the ball is directed downward. So, the acceleration is also directed downward. For a body moving along the vertical, and to differentiate the symbols used from horizontal motions, the distance traveled by the body along the vertical is y, and the acceleration is termed as acceleration due to gravity. The symbol is g. For a body thrown upward or released from a height or thrown upward then moved downward after reaching the maximum height, is there any part of the motion where the acceleration is not directed downward? None. The direction of the acceleration of a freely falling body is always directed downward. If only the magnitude is used to express the acceleration, acceleration due to gravity is negative. The values of acceleration due to gravity, g, in the MKS system, negative 9.8 meters per second square. In the CGS system, negative 980 centimeters per second square. And in the FPS system, negative 32 feet per second square. The quantities involved in a uniformly accelerated motion and freely falling body and the signs may be affected by the direction of the motion. For upward motion, the distance traveled, y, is positive if above the initial position. The velocity is positive, the time of motion is positive, and the acceleration due to gravity is negative. For a freely falling body while moving downward, the distance traveled y is negative if below the initial position. The velocity is negative. The time of travel is positive. And the acceleration due to gravity is negative. A freely falling body is uniformly accelerated. Can we use the equations of uniformly accelerated motion or equations of kinematics for freely falling bodies? If you say yes, then you're right. These bodies are both moving with constant acceleration. What are the equations of kinematics modified for freely falling bodies? This table presents the equations of kinematics and the modifications for freely falling bodies. The first, second, and third equations are: the first equation, the final velocity is equal to the sum of initial velocity and the product of acceleration and time. The second equation is the distance traveled is equal to the sum of the product of initial velocity and time, and the half of the product of acceleration in the square of time. The first of the third equation of kinematics is the distance traveled is equal to the ratio of the difference in the squares of final and initial velocities and twice of the acceleration. The second and the third equation is the square of final velocity is equal to the sum of the square of initial velocity and the product of twice the acceleration and distance traveled. For freely falling bodies, the equations were modified by replacing the distance traveled x by y and the acceleration by acceleration due to gravity g. For a body released from vertical distance, the initial velocity is 0, and the equations are: for the first equation, the final velocity is equal to the product of acceleration due to gravity and time of motion. The second equation is the distance traveled is equal to 1/2 of the product of acceleration due to gravity and the square of time. The first of the third equation, the distance traveled is equal to the ratio of the square of final velocity and twice of acceleration due to gravity. And the second of the third equation, the square of final velocity is equal to twice of the product of acceleration due to gravity and distance traveled. Given these equations modified for freely falling bodies, how will you obtain the height of a building using a 1 peso coin? Now let's have an example. Applying the equations modified for freely falling bodies. A ball was thrown upward with the speed of 20 meters per second. Letter A, how high did the ball go? Letter B, how long did it take the ball to reach the maximum height? The problem is illustrated showing the body in motion, the velocities, time to reach the maximum height, and distance along the vertical covered by the freely falling body. The provided information from the problem are initial velocity, 20 meters per second. The final velocity is 0. Why 0? Because the body had to zero its velocity before it can move to the opposite direction, downward. Acceleration due to gravity is negative 9.8 meters per second square. What are asked to determine in the problem? The maximum height reached by the ball, y sub max, and the time taken by the ball to reach the maximum height, t sub up. The formula to use in computing for the required are: for letter A, y sub max is equal to the ratio of the difference in the squares of final velocity and initial velocity, and twice of the acceleration due to gravity. And the time sub up is equal to the ratio of the difference in the final and initial velocities and acceleration due to gravity. Substitution and calculation. Substitute the final velocity, 0. Initial velocity, 20 meters per second. Positive because the ball is moving up. And acceleration due to gravity, negative 9.8 meters per second square. Square the velocities and divide by the product of 2 and negative 9.8 meters per second square. The result is y sub max equals 20.41 meters. For letter B, time sub up. Substitute the velocities in the acceleration due to gravity. Divide. And the result is time sub up is equal to 2.04 seconds. The answers are y sub max is 20.41 meters. The displacement of the ball is positive because it's above the initial or reference position. The time to reach the maximum height is 2.04 seconds. It's always positive. These answers may be checked using the second equation, y equals v sub I times t plus 1/2 times g times t squared. Substituting the time computed, 2.04 seconds, and other provided information. To say it's correct, the result must be 20.41 meters. Using this problem, the provided information in the computed quantities. Let's analyze the motion of a freely falling body and provide the answers to some misconceptions that may exist. How does the time to reach the maximum height, t sub up, compare with the time to return to the same level, t sub down? Some says the time taken by the body to reach the maximum height is longer than the time to return to the same level, because as the body moves up, the velocity is decreasing, and while moving downward, the velocity is increasing. Earlier, the time to reach the maximum height, t sub up, was computed as 2.04 seconds, and the displacement of the ball to the highest point is 20.41 meters. To determine t sub down, this working equation will be used. T sub down is equal to the square root of twice of y sub max and acceleration due to gravity. Substitute the computed y sub max and the acceleration due to gravity. Perform the operations. And the time sub down is 2.04 seconds. Time sub up is equal to time sub down. This means the time elapsed for the ball to reach the maximum height is the same as the time for the ball to return to the same level. This time, let's analyze the velocity of the freely falling body. We had mentioned earlier that when the body is released from a vertical distance, the initial velocity is 0. If the body is at its highest point, or the maximum height, the velocity is 0. How about the speed of the body at the same level, v sub a and v sub v? This is the question. For a body thrown vertically upward, how does the speed upward and speed downward at the same level compare? With the same information given earlier, initial velocity is 20 meters per second. Final velocity is 0. Acceleration due to gravity, negative 9.8 meters per second square. And the computed quantities, y sub max and T sub up. Taking the 10 meters position from the point of release upward, the velocity at 10 meters from release is V sub A, and the velocity at 10 meters before reaching the point of release on its way down is V sub B. Let's calculate these quantities. To solve for V sub A, the third equation of kinematics will be used. V sub A is equal to the square root of the sum of the square of initial velocity and the product of twice the acceleration and the distance traveled. Substituting the given information, initial velocity, acceleration due to gravity, and distance traveled, 10 meters. Performing the operations, the velocity sub A is 14.3 meters per second. Positive because the body is moving up. To determine V sub D, we will consider the downward motion only, starting from the highest point, 20.41 meters from the point of release. The velocity at the highest point is 0. Before the velocity is calculated, we have to determine first the time elapsed for the body to move downward to the same level. Time sub D equals the square root of 2y divided by g from the second equation of kinematics. Substitute the distance traveled from the highest point down, negative 10.41 meters and negative 9.8 meters per second square. Why is the distance traveled negative? Because the reference point now is the highest point and the ball is moving downward. 10.41 meters is the difference between y sub max and 10 meters. Perform the operations, and the time sub B is 1.46 seconds. Using the first equation of kinematics, obtain the velocity sub B. Substitute the acceleration due to gravity and the computed time. Perform the operations. The velocity sub B is negative 14.3 meters per second. Why negative? The ball is moving downward. Therefore, at the same level, the speed upward and the speed downward of a freely falling body have the same magnitudes. Let's consider this problem as the second example. A man on top of a 30 meters tall building threw a ball vertically upward with a speed of 15 meters per second. How long did it take the ball to hit the ground? B. What is the speed of the ball when it hit the ground? The illustration shows 3 points in the motion of the body. A at the start of the motion, at the top of the building. B at the highest point of the motion. And C the point when the ball hits the ground. The instantaneous velocities and time are named using these points. The given information in this problem are velocity at point A, V sub A, which is the initial velocity of the ball, 15 meters per second. The height of the building, H sub B, 30 meters. And acceleration due to gravity, negative 9.8 meters per second square. The required in this problem are the total time of motion, T sub T, and the velocity of the ball when it hit the ground, V sub c. The formula to use in solving for the quantities required are: for the total time, T sub t is equal to T sub AB, the time for the ball to move from point A to point B, plus T sub BC, the time to travel from point B to C. But time sub AB and time sub BC are not given. These times can be solved. Time sub AB is equal to the ratio of the difference in the velocity at point B and the velocity at point A, and acceleration due to gravity. This was derived from the first equation of kinematics. Time sub BC is equal to the square root of the ratio of twice of y sub BC and acceleration due to gravity. This working equation was derived from the second equation of kinematics. But what is y sub BC? Y sub BC, the distance traveled by the ball from the highest point, point B, to the ground, point C. To obtain y sub BC, determine y sub AB plus the height of the building, h sub B. But what is y sub AB? Using the third equation of kinematics, y sub AB is equal to the ratio of the difference in the squares of the velocities at points B and A, and twice of the acceleration due to gravity. To obtain the velocity of the ball when it hit the ground, V sub C, the working equation should be V sub C equals V sub A plus G times T sub T. Substitution and calculation. Substitute the given velocities at point B, 0, and velocity at point A, 15 meters per second, and acceleration due to gravity, negative 9.8 meters per second square. Perform the operations. Y sub AB is equal to 11.48 meters. The distance traveled is positive because the ball moves upward. Substitute the obtained y sub AB to obtain y sub BC. Y sub BC is equal to negative 30 plus negative 11.48 meters. Why are the values negative? Because the reference point now is point B, the highest point, and the ball is moving downward below the reference point. Perform the operations, and the result, y sub BC is equal to negative 41.48 meters. Using the computed y sub BC, the time sub BC is obtained as the square root of the ratio of twice the distance traveled, negative 41.48 meters, and negative 9.8 meters per second square. Perform the operations. And the time sub BC is 2.91 seconds. To obtain time sub AB, substitute the values V sub B, 0, V sub A, 15 meters per second, and acceleration due to gravity, negative 9.8 meters per second square. Perform the operations. And the result, time sub AB is equal to 1.53 seconds. The total time of motion then is 1.53 seconds plus 2.91 seconds. The total time is 4.44 seconds. The second required, V sub C, is equal to 15 meters per second plus the product of negative 9.8 meters per second and 4.44 seconds. Perform the operations. V sub c is negative 28.51 meters per second. Why negative? Because the ball is moving downward. The final answers. A. Total time is 4.44 seconds. And B. Velocity when the ball hit the ground is negative 28.51 meters per second. Example number 3. A motorboat is approaching a bridge 24 meters from the water surface with constant speed of 12 meters per second. A man on the bridge released a ball. If the ball fell onto the boat, how far is the boat from a point on the water vertically below the man when the ball was released? This figure shows the bridge and the location of the boat when the ball was released. In this problem, we will use the symbol for the ball BA, for the boat BO, and for the bridge BR. The given information from the problem are: average velocity of the boat is 12 meters per second, height of the bridge is 24 meters, acceleration due to gravity is negative 9.8 meters per second square. The required in the problem is the distance traveled by the boat, which will measure the location of the boat when the ball was released. The formula to use is distance traveled x is equal to the product of average velocity of the boat and the time of travel of the boat. The time of travel of the boat is equal to the time of fall of the ball, which can be obtained from the square root of the ratio of twice of distance traveled by the ball, y sub dA, and acceleration due to gravity. The distance traveled by the ball, y sub dA, is equal to the height of the bridge. Substitution and calculation. Y sub dA is negative 24 meters, and why is the distance traveled by the ball negative? Because the ball is moving downward from the bridge, which is the reference point. Substitute the distance traveled by the ball and the acceleration due to gravity. Perform the operations. The time of fall of the ball is 2.21 seconds. This is also the time of travel of the boat. For the distance traveled by the boat, substitute the average velocity of the boat, 12 meters per second, and the computed time of travel of the boat. Compute. And the result, the distance traveled by the boat is 26.52 meters. And the answer, the boat is 26.52 meters away from the point directly below the man on the bridge. That problem completes the discussion about freely falling bodies. It It's time to test your learning on this topic from this video lesson. Solve these problems completely on separate sheets of paper. When you're done, have your solutions checked by your instructor or professor. The first problem is, a boy accidentally pushed a path from the window of a building 30 meters high. The path was caught by a tarp hanging horizontally 10 meters from the ground after 1.5 seconds. Calculate A, the height of the window from the ground, and B, the speed of the path when it was caught by the tarp. The second problem is, a baseball player hit the ball and flew vertically upward with 24 meters per second speed. When it fell back, it was caught by the pitcher. How high did the ball go? How long did it take for the ball to reach the maximum height? If the pitcher ran steadily from his position 18.2 meters from the point where he caught the ball, what is the pitcher's velocity? Hope that you acquired what you are supposed to learn on this topic through the video lesson you have just watched. If you feel that other students will also learn from this presentation, don't forget to like and share this video. Learning physics should be easy and enjoyable. Video lessons in this channel can do that for you. If you have not subscribed to this channel before, I'm inviting you now to subscribe for you to view all the video lessons in this channel and the other upcoming videos. Thank you for watching this video. God bless, keep safe, and good luck.